Let's do the same thing, only we're trying to minimize mileage. We're not flying this time, we're driving. And the vertex edge graph below represents the miles between each city. We're going to begin and end at Chicago. So we could do the same thing and just list all our possibilities and bust our brains trying to do it, and that's fine. But I'm going to show you a method that is very methodical, because that's what a method is. Anyway, let's begin and end in Chicago. Let's put a C right here. If I start in Chicago, I have 3 possible places I could go. So let's branch this thing off into 3 different places. This is going to get really big really fast, which is one reason that the brute force method, we're going to realize this in a few minutes, is not the most practical thing to use. So we're going to start in Chicago. We could go to St. Louis, we could go to Minneapolis, or we could go to New Orleans, or New Orleans, depending on how you want to pronounce it. Okay, let's pretend like we go Chicago, St. Louis. Well, if that's the case, or St. Louis, depending on how you pronounce it, I could split off from St. Louis and go to either Minneapolis or New Orleans. Okay, if I go Chicago, Minneapolis, then I have 2 options from here. So I'd have St. Louis or New Orleans. And if I go Chicago, New Orleans, then I have St. Louis or Minneapolis. And so now I'm going to keep tracing these branches down and just filling in the entire path. So if I go Chicago, St. Louis, Minneapolis, Chicago, St. Louis, Minneapolis, now I have no choice but to go to New Orleans. And then I have to go back to Chicago. So we just traced one of the paths. Let's keep going. I say path. Technically, it's a circuit. We began in Chicago, we ended in Chicago. So Chicago, St. Louis. I keep pointing here for Chicago. That's not right. Chicago, St. Louis. My geography's off. St. Louis, New Orleans, Minneapolis. We have to go back to Chicago. C, M, S. C, M, S. We have to go to New Orleans now. And we have to go back home. C, M, N. Haven't been to St. Louis yet. Back to Chicago. We're seeing where we haven't gone, and we go there. Now, at the very beginning, we had options, and then our options got limited, and now our options are even more limited. C, N, S, M. C, N, M, S, C. All right, what I like to do at this point is fill in the dollar amounts, and actually, as it was with this problem, what you have forward is also what you have backward. So we're going to see some duplicates here. Notice there are 6 ways that we have listed, and 3 of them, there will really be 3 unique ones. So let's put the dollar amounts in. Yeah, we'll put them in red, even though it's money. We're paying it. Chicago to St. Louis is $270, and instead of just going a little line by line, I'm going to just find all my CS's and put 270. CS 270. There we go. We have those. CM is 400. So 400. Every time I see CM, I'm going to put 400. Oops. 400. CN is 910. 910. 910. Let's see, what else do we have? SM. SM is 550. Every SM or MS is 550. And then SN. SN is 670. SN 670. Oops, I don't know why I put a 2 there. 670 and 670. I missed an SM right here. There's a lot of room for error here, so we have to be very careful. And NM is 1260. 1260. 1260. And there's another one right here, 1260. All right, so we're going to add them up. And when we do, we'll just put the totals at the bottom. And again, we're going to have some duplicates, and that is okay. That is totally okay. So here we go. This is the boring part where I'm just adding, and you can't see what I'm typing. Actually, I'm doing this in my head, I promise. All right, first one, I got 2990. Hey, you want a shortcut? Here's the shortcut. I'm going to find the other one that is exactly like this, only in reverse. It's also $29.90. So let's read it backwards. CNMSC. So CNMSC. Here's the other $29.90. All right, let's keep going. 270, 670, 1260, 400. This one is 2600. So far, it's the cheaper one. Well, I say cheaper, it's less miles. 2600, and I'm going to read it backwards. CMNSC. CMNSC, so 2600, which automatically tells me that these two must be the same. So 400, 550, 670, and 910, and 2530, and this one's going to be the same. 2530, there it is. Okay, now let's also actually answer the question. And on this one, the question was answered because we already had like ADBCA, or it's reverse. Here, it's a little bit more, I don't know, vertical, harder to tell. I'm going to actually write it out, and I don't have much room here. I'm going to put it beneath the graph. And you can go in either direction. I'm just going to start at the top and go down. So here it is. C, M, Chicago, Minneapolis, St. Louis, New Orleans, back to Chicago, and the total mileage is 2,530 miles, and that is the cheapest one, okay? So let's compare methods. We have two methods here. One of them is let's just bust our brains trying to figure out every possibility, and the other one is very methodical, listing everything. There's kind of a method to it. A lot of people don't like this one, even though there's kind of a pattern to it, because they think it's just easier to list it all out. So we're going to talk about how many possibilities you normally have, and we'll deal with that as we move forward. So here we go. Find the cheapest path for each of these by using the brute force method, begin and end at A for each. So there's this one, and then there's some on the back side of this. So I'm going to actually start with this one, and you can use whichever method you want. I think this one is going to be super duper easy to use just by going, hey, A, B, C, and then back to A, or A, C, B, and then back to A. And I'm doing this example because I just want to reinforce one more time that everything you do forward, you can also do backward. Everything. So A to B is 10, so 10. B to C is 13, and I don't think anybody's going to be surprised that these two are going to be the exact same thing because I don't have many options. I really don't have many options at all. So this one's $25, and this one's $25, whatever that represents. It's not airfare for sure. That's too cheap. I wouldn't want to fly on a plane if it's only going to cost me $10 to get somewhere. I don't trust that pilot. Anyway, I need to see your pilot's license, sir. But again, the idea is this. I only really have, in this case, one unique way of doing it because it's really the same forward and backward. Now, here's the difference. If I had a directed graph, like if it cost $10 to go this way but $12 to go the other way, everything changes. We would have double. Okay? Let's keep moving. Let's do this one. We're going to begin and end at A for each. And this one gets really tricky with this method, and I love this method, but I'm actually just going to bust my brain to list them all. All right, so let's lower the camera a little bit, and we shall begin and end at A. So here goes. A, and you just pick a place. Let's go alphabetical. A, B. Now we have to think ahead. If I go A, B, C, that's fantastic. Atlanta, Boston, Chicago. This is not geographically correct, by the way. Atlanta, Boston, Chicago, and then you're going to hit Erie, Pennsylvania, and Denver. Again, not geographically correct, but if I go bump, 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 yeah, that's great. But how are you going to get back to Atlanta? You're only going to hit each city once, which is really, truly how you minimize your cost or mileage or whatever. So if we're going to hit A, B, C, we have no choice but to go back to A, and we never finished our trip. If we're a traveling salesperson, then you're going to have to hit all the cities, right? So we have A, B. We have to go down here. Let's go E. Why? Because I feel like it. And then let's go D, and then let's go C, and then back to A. Okay? That's one way. Now, as I was tracing that, if you were like, oh, but I see another way. Fine, great, do it. Let's do the other way. A, B. Maybe you didn't want to go to E, you wanted to go to D instead. And then you wanted to go to E, and then you want to go to C, and then you want to go back to A. And that's cool. That's fine. Let's hit C first. A, C, E, D, B, A. Okay, and let's do a little bit more. We could start at A and go C. Maybe we don't go to E, maybe we go to D. D, E, B, A. All right, so here's the fun part. We actually have duplicated some stuff. There are only 2 unique paths on this one. Interesting, huh? You'll actually, as far as I can tell, you will never, ever cross that one right there. That B to C 14, never will. You just won't. It won't happen. Because you're going to have to come down one side and back up the other. You'll never go in between them. All right, just throwing that out there. Sometimes you have useless things. So there are a couple duplicates. A, B, E, D, C, A. A, there it is, the top one. A, B, E, D, C, A. A, B, E, D, C, A. If you want to, you can mark that one out. Or you can mark the top one out. Either way, because it's not a directed graph. All right, A, B, D, E, C, A, A, B, D, E, C, A. So you're telling me all that work I did down there was useless? Yeah, sorry. All right, the distance between A and B is 17. Distance between B and E is 21. The distance between E and D is 23. DC is 22. CA is 13. EC is 15. And BD is 11. And we will add those together. I would not use a calculator. It's the end of the day and my brain is exhausted. So here goes. This one's going to be 96. And the other one is going to be 17, 11, 23, 15, 13, 79. All right, there's your cheaper one. And again, if you reverse the order, same thing. Okay, now they get crazy. If I'm going to list all of my possibilities, then we're going to have an explosion here. All right, so here goes. When I had 4 cities all connected, so there was no city on here that wasn't connected to another one. 4 cities all connected. I had 6 possibilities, but I really had 3, right? I really had 3. So let's start filling in this graph. If I have 4 vertices, and they're all connected, each vertex is connected, it's undirected, so it's not different going from one place to the other than it is coming back. Then I had 3 possibilities. When I had, and here's the easy one, 3 vertices all connected, I really just had 1 possibility. I mean, I can list it twice, but again, it's the reverse of it. So I had 1 possibility. If I have 5 vertices, good luck with this one, okay? This one would be nasty. It's about to explode, y'all. It is about to explode. Let's start at A. By the way, I'm not going to finish this one. And the reason I'm not is because it's just so big. It's not worth our trouble. I'm just being honest. If I start at A, then I have 4 possibilities of where I could go. I could go B, C, D, or E. If I go to B, then I still have 3 possibilities of where I could go. I could go C, D, E. If I do this, I could go D, E. If I do this, I could go C, E. And if I do this, I could go C, D. You see how this is getting really big really fast? Which puts me to E and then back to A. Puts me to D and then back to A. A, B, C, D, E. A. A, B, E, D. I don't know why I'm reading them backwards. C and then back to A. A, B, E, C. I need a D here and then back to A. A, B, E, D. I need a C here and then back to A. We're only a fourth of the way through. I flew through that. And we still haven't done this one, or this one. Okay, so let's stop and think for just a second. I start with 1, I go to 4, and then 3 possibilities, and then 2 possibilities. What I'm really doing is this. Okay, check this out. If I had, this is fun. If I had 5 vertices, then what I really have is 4 possibilities, and then 3 possibilities, 1, 2, 3, and then 2 possibilities, and then 1 possibility. See what I'm doing here? This is really 4 factorial. Now, I know you're like, but I have 5 vertices. Well, it's 1 less, okay? Trust me. 5 vertices, and then I really have 4 times 3 times 2 times 1. It actually is the same if I had 4 vertices. Here, let's do this one. If I had 4 vertices, then I would have 3 possibilities times 2 each times 1 each. So I'd really have 3 factorial. So whatever the number of vertices is, it's always 1 less. But I'm lying to you because it's a little bit trickier than that too. Okay, again, there are some assumptions. One of the assumptions is this, that all the vertices are connected, which is why I'm not talking about this guy right here, because they're not all connected. We haven't connected D and A. We haven't connected E and A. There's some disconnect there to A. So this one doesn't really fit our patterns we're looking for down here. But if I was to do this one right here, it looks like I would have 4 factorial, which, by the way, is 24. I would have 24, but I'm really not going to have 24 because we have duplicates. I'm going to have half that many, so I'm going to have 12. Or if I had this, I'd have 6. I don't really have 6. We already decided that. I don't have 6. I have half that many. I have 3. Okay. I'm going through all this to reinforce some old ideas, but I'm also going to fill in my chart. This would be 12. If I asked you to do this one, yeah, have fun. Have a lot of fun with this one. Here's the way this one would be. I would have 6 vertices. That would be 5 factorial. But it really wouldn't be. I would divide it by 2, which will spare you a little bit of trouble. 5 factorial is 120. We'll divide that by 2, and we're going to get 60. Yay! That's going to be fun. So 60. All right, you ready for some crazy mathematics? It's going to be beautiful. You're going to love it. What we're going to do is find out how big these things get, and then we're going to just talk about how impractical it can truly be to list them all with the brute force method. If we had 7 vertices, we'd have 360. We had 8 vertices, we'd have 2,520. Okay, and then at this point you're like, all right, fine, so I won't do it. I'll let a computer do it. Sure. Yeah, we'll go with that. 9 vertices, 20,160. 10 vertices, 181,440. Let's suppose you wanted 20 vertices. Here we go. You ready? 6 times 10 to the 16. That is huge. A computer would take way too long to do that, even our fastest computers. All right? So here is the deal. There has to be a better way. I will tell you that the brute force method always finds the best, but what if you have an enormous problem? Even with a computer, it's going to take forever. So when you type something in your GPS, it's doing algorithms. Some of them, I don't know exactly what it is doing, but it is finding paths that would be shortest, but there's no way it could explore every possibility unless it's like a super duper short route. So when your GPS is thinking and it's like loading maps, and it's thinking, it's going through a lot of possibilities, whether it's with the brute force method or some of the other methods that we're going to learn later.